What is going on, guys? My name is Amos and I'm back again with another video. So this is going to be the last video in chapter 1, and this is going to end our discussion on propositional logic or mathematical logic. So we're going to start something new in the next video. I believe we're going to start les ensembles. So in today's video, we want to talk about les quantificateurs multiples. So we want to look at a situation where we have a quantified statement that has maybe something like two quelque soit or maybe quelque soit and il existe, and where elements x and y are taken from maybe the same set or maybe two different sets. So when is a proposition, when is such a proposition going to be true? So that is what we want to establish in today's video. So let's get started. Now, suppose we had the proposition for every x in the set A, and for every y in the set B. When is the proposition Pxy going to be true? When is the proposition Pxy going to be true? Well, this is going to be easy. So the proposition Pxy is going to be true. So this is going to be true if any element x taken from the set A and any element y taken from the set B verify the property Pxy. So if any x in A and any x in A and any x in A and any y any y in B satisfy the property Pxy, then the proposition is going to be true. The quantified proposition for every x in A, for every y in B is true if and only if any element x taken from the set A and any element y taken from the set B are going to satisfy the property xy. All right, or P of xy, that is. And we can also have something like il existe x dans A and il existe y dans B, such that we have P of xy. So if we can find at least one element in A and at least one element in B that satisfy the proposition or that satisfy the property P of xy, then the quantified proposition il existe x dans A, il existe y dans B, P of xy is going to be true. So if we can find at least one element in A and one element in B such that the property P of xy is true, then the proposition is also going to be true. Now, one thing that you have to keep in mind and that you have to be very cautious of is how we can create many such kinds of propositions. Is we can sometimes try to combine a quelque soit and an il existe. So you have to be very careful in terms of what they actually mean or what their truth values are going to be. So what are some of the rules that you guys are supposed to know, or some of the important points you guys are supposed to take note? So whenever we have this, quelque soit x dans A and quelque soit y dans B, and then we have the property P of xy, well, this is going to be equivalent to quelque soit y dans B, quelque soit x dans A, and then the property Pxy. So we can basically commute these two operations. So this can come here and this can come here. So this is only true if we are dealing with the same, quantifier. So in this case, we are dealing with the quelque soit quantifier. That is why we are able to do this. So we can do the same if we had il existe x dans A, il existe y dans B, such that the property Pxy is given, and il existe. So this can be changed into an il existe y dans B, il existe y dans x dans A. Il existe x dans A. So il existe x dans A, such that the property P of xy. So this is what we have. So we can commute whenever we have the same quantifier. Now, if the quantifiers are different, for example, quel que soit x dans 1, quel que soit x dans 1, and maybe I had il existe y dans b, such that the property pxy. Well, this is not equivalent to writing this. Il existe y dans b, quel que soit x dans 1, and such that the property is given. A certain property is given. So these two are not equivalent. So you can only commute whenever you have the same quantifiers. If you have different quantifiers, well, you cannot commute. Thank you guys for watching, and I'll see you in the next video.